Imagine this. Tomorrow morning, every drop of oil on Earth simply vanishes. Not depleted slowly, not replaced by alternatives, but gone entirely, right now. What happens? Within hours, the chaos begins. Delivery trucks stop moving because they run out of fuel. Ambulances cannot respond to emergencies. Power plants that generate electricity for millions shut down. Planes carrying people across continents are grounded. The internet slows to a crawl. By the next day, supermarket shelves begin emptying as supply chains collapse. Within a week, civilization as we know it begins to unravel. This is not dystopian fiction. This is the reality of our world in the 21st century. For over 100 years, oil has been the lifeblood of human civilization. It is the substance that built our cities, powers our transportation, heats our homes, and fuels our industries. Yet most people know remarkably little about what oil actually is, where it comes from, or why it has become so indispensable to our survival. The story of oil is the story of how humans transformed the planet. It is a story of scientific discovery, geopolitical conflict, technological innovation, and environmental consequence. But more than anything, it is a story about how we became dependent on a single resource, and why that dependency shapes everything we do. This is the essential knowledge you need to understand oil. This is what you need to know. What is oil really? When you hold a bottle of crude oil in your hand, you are holding something fundamentally unusual. It is thick, dark, and sticky. It smells pungent and chemical. You cannot drink it, you cannot breathe it in large quantities without damaging your lungs, and you certainly cannot touch it without your hands becoming stained for hours. Yet this substance, seemingly so unremarkable, is one of the most valuable commodities on Earth. Scientifically, crude oil is a complex mixture of hydrocarbons. Hydrocarbons are compounds made of hydrogen and carbon atoms bonded together in various combinations. Some molecules in crude oil are simple with just a few atoms. Others are extraordinarily complex, containing hundreds of atoms arranged in intricate structures. This mixture of different hydrocarbons is what gives oil its unique properties and its extraordinary versatility. But here is what makes oil truly special. It contains enormous amounts of energy stored in chemical bonds. When you burn a single gallon of gasoline, you release energy equivalent to working continuously at 100 horsepower for 2 hours. This energy density makes oil extraordinarily efficient at powering our world. No alternative energy source we have discovered comes close to this combination of energy density, portability, and ease of use. This is why oil is called a fossil fuel. It is called this not because it is made from dinosaurs, as popular culture suggests, but because it is made from ancient organic matter. Millions of years ago, plants and animals lived, died, and fell to the bottom of ancient oceans and seas. Over time, more and more layers of sediment buried this organic material deeper and deeper into the earth. Heat and pressure, applied over millions of years, transformed this dead matter into the liquid we call crude oil. The key word here is millions. The timescale is almost incomprehensible to human minds. Oil is not being created in any meaningful quantity today. Every drop of oil we pump from the ground was created in a prehistoric era that no human will ever see again. This fundamental fact, more than any other, explains why oil has become the strategic resource that defines global politics. The origins of oil, a story millions of years old. To understand where oil comes from, we must travel back in time. We must journey back millions of years to a period when the Earth looked radically different from today. In many places, vast ancient oceans covered what is now dry land. These oceans teemed with life. Trillions of tiny organisms, plants, and animals lived and died in these waters. When they died, their bodies drifted to the ocean floor. At the bottom of these ancient oceans, the dead organisms accumulated layer after layer after layer. Over thousands of years, millions of years, more sediment was deposited on top of this organic material. Sand became sandstone, mud became shale. The weight of all these layers pressing down from above was immense. The deeper the organic material went, the hotter it became, because the Earth's interior is a furnace of heat. This combination of heat and pressure, applied over millions of years, is the alchemy that transforms organic matter into oil. The process is called catagenesis. Chemical bonds break and reform. Complex molecules are broken down into simpler ones. The process continues for eons until the conditions are just right and the organic material transforms into liquid hydrocarbons. This liquid, being less dense than rock, begins to migrate slowly through the porous rock layers, moving upward toward the surface. The oil would eventually escape to the surface and dissipate into the atmosphere were it not for one crucial thing: a seal. Impermeable rock layers, such as shale, can trap the oil beneath them. If the underground geology is just right, the oil becomes trapped in a reservoir. These reservoirs are not underground lakes or rivers, despite what many people imagine. Instead, the oil sits within the pores and cracks of porous rock, held in place by the pressure from the weight of rock above and the impermeable seal that surrounds it. These reservoirs are scattered around the world in different geological formations. Some contain vast quantities of oil, others contain only small amounts. The location of these reservoirs is determined by ancient geography and geology, factors completely beyond human control. This is why oil is not found everywhere. It is found only where the ancient conditions were right for its formation and preservation. And this, in turn, is why certain parts of the world have enormous geopolitical power, while other regions have none. How humans discovered oil. Humans did not invent oil, but humans did discover it, recognize its value, and transform it from a curiosity into the foundation of industrial civilization. This discovery did not happen overnight. It happened gradually as different cultures noticed that black, sticky substance seeping from the ground in various parts of the world. In ancient Persia, thousands of years before modern industry, people noticed oil seeping from the ground near the Caspian Sea. They called it naphtha. In China, centuries before the Industrial Revolution, oil was used for lighting and in warfare. The Chinese burned crude oil in lamps, and they even invented a primitive form of oil drilling, using bamboo to dig wells that reached over 800 meters deep. Yet none of these ancient civilizations discovered oil's true potential. The transformation of oil into a crucial commodity happened during the Industrial Revolution of the 19th century. The primary fuel-driving industry and transportation during this era was coal. Millions of tons of coal were mined and burned each year to power factories, heat homes, and drive steam engines. But coal had significant limitations. It was dirty, it was heavy, it was difficult to transport, and mining it was dangerous and destructive. Then, in the middle of the 19th century, chemists began experimenting with crude oil. They discovered that when crude oil was heated and separated into different components, one component called kerosene was particularly useful for lighting lamps. Before electricity became widespread, kerosene lamps lit homes and businesses across the world. This discovery suddenly made crude oil valuable. The first commercial oil well in North America was drilled in Pennsylvania in 1859 by a man named Edwin Drake. The Pennsylvania oil boom that followed was one of the most transformative events in human history, though few people remember it today. Within a few years, hundreds of oil wells were drilled across Pennsylvania. A new industry was born. But this was only the beginning. The true transformation came when the internal combustion engine was invented. Suddenly, a new component of crude oil, gasoline, became extraordinarily valuable. Cars, trucks, airplanes, and ships could all run on this fuel. By the 1920s, oil had become the dominant energy source in industrialized nations. The age of coal was ending, the age of oil was beginning, and nothing would ever be the same. How oil is extracted. Getting oil out of the ground is one of the most technically demanding processes humans have ever devised. The process begins with exploration. Geologists use sophisticated instruments to scan beneath the surface of the Earth, looking for the telltale signs of an oil reservoir. Seismic surveys, which use sound waves to map underground structures, help identify promising locations. When a potentially productive location is identified, the difficult and expensive work of drilling begins. There are two primary methods of drilling for oil: onshore and offshore. Onshore drilling happens on land. A drilling rig is set up above the location where geologists believe oil exists. A drill bit, rotating at thousands of revolutions per minute, begins boring through layers of rock. As the hole deepens, hollow pipes called casings are inserted to reinforce the well and prevent it from collapsing. The deeper the hole goes, the hotter the rock becomes, and the more extreme the pressure. Some oil wells must bore through miles of rock to reach a reservoir. Offshore drilling, which occurs in oceans and seas, is even more challenging. Massive steel platforms, taller than office buildings, are anchored to the seafloor. These platforms can weigh thousands of tons. In the North Sea, off the coast of Scotland, offshore platforms operate in waters that are often stormy and treacherous. In the Gulf of Mexico, platforms drill in water over 1,000 meters deep. The engineering required to keep these platforms stable and operational is extraordinary. When a drill finally reaches the oil reservoir, a series of pressurized fluids and devices are used to ensure that the crude oil flows upward to the surface. In the early years of oil drilling, pressure from the natural gas dissolved in the oil would push crude to the surface on its own. But as reservoirs age and pressure decreases, this becomes impossible. Powerful pumps, working continuously, must be used to extract the remaining oil. The crude oil that flows from the well contains not just oil, but salt water, natural gas, and other substances. This mixture must be transported to facilities where oil is separated from water and other contaminants. This is the beginning of the journey of crude oil from deep beneath the earth to the refined products that power our world. From crude to useful, refining oil. Crude oil, as it emerges from the ground, is not directly useful. It is a complex mixture of hydrocarbons of varying sizes and properties. Some molecules are light and volatile, evaporating easily into gas. Others are heavy and thick, remaining solid at room temperature. To transform crude oil into products we can actually use, an intricate process called refining is necessary. A refinery is one of the most complex industrial facilities on Earth. A large refinery might sprawl across several hundred acres and employ hundreds of workers. Pipelines crisscross the facility. Massive towers, some taller than 100 meters, rise into the sky. Furnaces operate continuously, heating crude oil to temperatures of up to 400 degrees Celsius. This intense heat is essential to the refining process. The primary process used in refineries is fractional distillation. Crude oil is heated and vaporized, then fed into a tall column called a fractionating tower. This tower is hotter at the bottom and cooler at the top. Molecules with different boiling points rise different distances up the tower before condensing back into liquid. Light molecules, like gasoline and kerosene, rise high in the tower before condensing. Heavy molecules, like fuel oil and bitumen, condense quickly at the bottom. The result of this process is a separation of crude oil into useful products. The lightest fraction, at the top of the tower, is petroleum gas used for cooking and heating. Below that is gasoline, the fuel that powers cars. Next comes kerosene, used for jet fuel and heating. Below that is diesel, used in trucks, ships, and industrial machinery. At the bottom of the column are heavy fuel oils and bitumen, used for power generation and road construction. But refining is only the beginning of oil's transformation. The components separated in the refinery are then transported to chemical plants, where they are broken down further and recombined into thousands of different products. Gasoline is blended with various additives to improve performance. Crude oil components become the feedstock for plastics, pesticides, pharmaceuticals, cosmetics, and countless other products. Every aspect of modern life, in ways most people never realize, depends on oil. Why the world depends on oil? When you think of oil, you likely think of gasoline, the fuel that powers the cars we drive, the trucks that deliver goods, the airplanes that fly us across continents. And this is indeed a massive use of oil. Transportation accounts for more than half of global oil consumption. Roughly 80 million barrels of oil are consumed globally every single day, and more than 40 million of those barrels are burned in transportation. But transportation is only part of the story. Oil is the foundation of modern agriculture, and agriculture feeds 8 billion people. Tractors and farm equipment run on diesel fuel refined from oil. Fertilizers, which are essential for growing enough food to feed the world, are manufactured using oil as a raw material. Without oil, farming would revert to pre-industrial methods, and global food production would collapse to a fraction of current levels. Manufacturing depends on oil in ways most people never consider. The plastic in your phone, your computer, your clothes, your furniture, and countless other products is made from oil. In fact, roughly 2% of global oil consumption becomes plastic. That might sound small, but plastic has become so ubiquitous in modern life that civilization would barely function without it. medical devices, food packaging, building materials, insulation, components for electronics and machinery. All of this depends on oil. Electricity generation also depends on oil. While coal and natural gas generate more electricity than oil does, oil-fired power plants are still widespread, particularly in regions where other fuels are difficult to access. In the Caribbean, in parts of Africa, and in some island nations, oil is the primary fuel for electricity generation. The depth of oil's integration into modern civilization cannot be overstated. Clothing is transported in ships powered by oil and plastic shipping containers. Food travels thousands of miles in refrigerated trucks powered by oil to reach supermarkets. Medicine is packaged in oil-derived plastic and delivered in ambulances powered by oil. The hospital that treats you might be heated by oil. The electricity that keeps the lights on might come from oil-fired generators. Oil is not just an energy source. It is the circulatory system of the modern world. Why oil is so valuable? Oil is valuable for three fundamental reasons. First, it is a non-renewable resource. The oil we pump from the ground today will never be replaced on any timescale meaningful to human civilization. It took millions of years to create, and we are consuming it in decades. This scarcity, more than anything else, gives oil its value. If oil were unlimited, it would be worthless. But because it is finite, and because the world needs it desperately, whoever controls oil controls a precious commodity. Second, oil has extraordinary energy density. A single liter of gasoline contains roughly the same amount of energy as 10 kilograms of coal. This energy density, combined with the fact that oil is a liquid and therefore easy to transport and store, makes it uniquely suited to powering vehicles and machinery. No renewable energy source we currently have developed comes close to matching this combination of properties. Solar panels and wind turbines generate electricity, but that electricity cannot easily be used to power an airplane or a cargo ship, which are among the most energy-intensive activities in the world. Third, oil is cheap. When you account for its energy content and versatility, oil is remarkably inexpensive compared to alternative energy sources. This cheapness is deceptive because it does not account for environmental costs, but in terms of pure economics, oil is hard to beat. A barrel of oil might cost $100, and that barrel contains roughly 1,700 kilowatt hours of energy. That works out to less than 6 cents per kilowatt hour of energy. It is almost impossible to compete with that price. But there is a fourth reason, less often discussed, that explains oil's value. Oil is familiar. The world's infrastructure is built around oil. Every car, truck, ship, and airplane that exists today has been designed to run on oil. Retrofitting this infrastructure to use alternative fuels would cost trillions of dollars and take decades to accomplish. The inertia of this infrastructure is enormous. Even if a better alternative to oil were invented tomorrow, it would take generations to replace oil as the world's primary energy source. These four factors together make oil not just valuable, but indispensable. And this is why oil has become the most strategic commodity in the world, and why control over oil reserves translates directly into global power. Oil and global power. History is the story of nations struggling for power. In ancient times, power came from military strength and geographic position. In medieval times, it came from land and agricultural production. In the industrial age, it came from coal and steel. But in the modern era, power comes from oil. Consider Saudi Arabia. In 1900, it was a poor, isolated region of the Middle East, home to nomadic tribes and desert Bedouins. It had no industry, no modern infrastructure, and no particular strategic importance. But beneath its sands lay something extraordinary: the largest oil reserves in the world. Today, Saudi Arabia is one of the most powerful nations on Earth. Its decisions about oil production shape global economies. Its political influence extends from Washington to Beijing. It commands the respect of presidents and prime ministers. All of this power flows from a single fact: Saudi Arabia controls immense quantities of oil. The geopolitics of oil has shaped the modern world in ways most people do not realize. After World War II, as the United States emerged as a superpower, one of the primary objectives of American foreign policy was to ensure stable access to oil. The strategic alliance between the United States and Saudi Arabia, which has endured for over 70 years, is fundamentally about oil. Whenever instability threatens Middle Eastern oil supplies, the United States becomes intensely engaged with the region, because instability there threatens global oil supplies, and threats to oil supplies threaten American economic interests. The global competition for oil resources has driven military conflicts, diplomatic crises, and international tensions. When Iraq invaded Kuwait in 1990, the United States led a coalition of nations in a war to restore Kuwait's independence. This war was partly about defending a smaller nation from aggression, but it was also fundamentally about oil. Kuwait sits atop vast oil reserves, and an Iraqi takeover would have allowed a single hostile nation to control a significant portion of global oil supplies. Oil has also shaped the relationships between regions. The Middle East produces more than a third of global oil, yet it has relatively small population and limited water resources. Its wealth and power flow entirely from oil. This has created a strange phenomenon in world geopolitics, an entire region whose importance to the global system is disproportionate to its population or traditional sources of power. Tiny oil-rich states wield influence far beyond their size. Meanwhile, resource-poor nations, no matter how large or populated, struggle to command global attention. The dark side of oil. Every barrel of oil that is pumped from the ground and burned has consequences. Some of these consequences are economic, some are political, but an increasing number are environmental, and they are becoming increasingly severe. When oil is burned, it releases carbon dioxide, a greenhouse gas, into the atmosphere. For over 150 years, since the beginning of the industrial age, we have been burning more and more oil, releasing more and more carbon dioxide. The concentration of carbon dioxide in the atmosphere has increased by more than 50% since the beginning of the industrial age. This increase is driving global warming. Temperatures are rising, weather patterns are shifting, extreme weather events are becoming more frequent and severe, ecosystems are being disrupted. Beyond climate change, oil extraction and refining create significant local environmental damage. Oil spills are perhaps the most visible disaster. In 2010, the Deepwater Horizon oil rig in the Gulf of Mexico exploded, killing 11 workers and releasing roughly 5 million barrels of oil into the ocean. The environmental damage was catastrophic. Marine life was poisoned. Ecosystems were disrupted. The economic impact on fishing and tourism in the region was enormous. But oil spills, as dramatic as they are, represent only a small fraction of the environmental damage caused by oil. Oil extraction contaminates groundwater with toxic chemicals. Oil refineries emit pollutants that create smog and respiratory disease. Communities near oil facilities suffer from higher rates of cancer and asthma. In Nigeria, decades of oil extraction have devastated the Niger Delta, one of the world's most ecologically important regions. There is also a social and political cost to our dependence on oil. Nations with large oil reserves often become victims of what economists call the resource curse. The sudden wealth from oil extraction can corrupt governments, fuel internal conflicts, and prevent economic diversification. Nations like Venezuela, with vast oil reserves, should be wealthy, yet they are poor and unstable, their economies crippled by dependence on a single resource, and their governments corrupted by oil wealth. The irony is painful. The resource that was supposed to bring prosperity instead brought instability and suffering. The future of oil. The oil industry faces an unprecedented challenge. For the first time in its history, alternative energy sources are becoming competitive with oil. Solar energy is becoming cheaper. Wind energy is becoming cheaper. Electric vehicles are becoming cheaper. Batteries, which can store electrical energy, are becoming more efficient and less expensive. These alternatives, which seemed like distant dreams just a decade ago, are now becoming reality. But there is a fundamental problem that must be understood. Transportation is not the only use of oil. Even if every car, truck, and airplane in the world was powered by electricity from renewable sources, that would only solve part of the oil dependence problem. Oil is still needed for plastics, for chemicals, for medicines, for countless products that simply cannot be made without oil. It will be decades, perhaps centuries, before oil is completely replaced. There is also the question of whether oil will run out. The short answer is not soon. When oil companies talk about reserves, they mean oil that has been discovered and is economically viable to extract with current technology. Current proven reserves would supply the world for roughly 50 more years at current consumption rates. But this calculation is constantly changing. As technology improves, previously uneconomical reserves become economical. As price rises, it becomes worth extracting oil from difficult locations. The true answer to how long oil will last is, nobody really knows. What is certain is that the transition away from oil will not be easy. The global infrastructure built around oil is enormous. The economic interests protecting oil are powerful. The political forces defending oil are strong. Alternative energy sources, while improving rapidly, still face significant technical challenges. Batteries for electric vehicles are getting better, but they cannot match the energy density of gasoline for long-haul trucking or aviation. Solar and wind are getting cheaper, but they produce electricity intermittently, requiring energy storage systems that do not yet exist at the necessary scale. The most likely scenario for the next few decades is this: oil will remain the dominant energy source, but its market share will slowly decline as renewable energy expands. This transition will take decades, not years. Oil will gradually become less central to human civilization, but it will remain important for many uses that have no practical substitute yet. The age of oil is ending, but the end will be a slow fade, not a sudden collapse. A world built on oil. We have journeyed from the ancient oceans where organic matter was transformed into liquid hydrocarbons over millions of years, to the modern refinery where crude oil becomes the products that power civilization. We have seen how oil, once just a curiosity, became the foundation of industrial civilization. We have explored the geopolitical consequences of oil dependence, the technological innovations that oil enabled, and the environmental costs that come with burning oil. The fundamental truth is this: the world we live in today was built on oil. The cities we inhabit, the food we eat, the medicine that keeps us alive, the devices we use to communicate, the energy that lights our homes and powers our technology. All of this in some way depends on oil. Remove oil from the equation, and modern civilization collapses. This is not hyperbole, this is simple fact. But understanding oil is not just about understanding the past or the present. It is about understanding the future. The future will be shaped by how we transition away from oil. Will we successfully develop renewable energy sources and alternative fuels that can eventually replace oil? Will we develop carbon capture technology that allows us to continue burning oil while removing the carbon from the atmosphere? Will we adapt our societies to use less energy overall? Or will we fail to transition and face increasingly severe consequences from climate change? These are questions that will define the lives of people alive today and everyone born in the future. The answer depends on the choices we make in the coming years, but it starts with understanding. It starts with knowing what oil is, where it comes from, why we depend on it so completely, and what the consequences of that dependence truly are. This is what you need to know about oil. This is the foundation of understanding not just energy, but modern civilization itself. The age of oil created the world we live in. What happens next, in the age beyond oil, will be determined by decisions made today. The stage is set, the future is unwritten, and we are the ones who will write it.